Hello everyone, I'm G. Karthik, Assistant Professor, IT Department, working in Kongonadu College of Engineering and Technology. Today we are going to see about K-means clustering in big data analytics. So before that, we see what is called as a clustering. So clustering is a one type of unsupervised techniques for grouping the similar objects. So grouping similar objects means in this diagram we having three different type of objects. So star, circle, and then diamond. So these three objects are combined together. So out of that, we are going to convert it as a clustering system based on that grouping similar objects. For example, we are going to combine the object star objects, and then after that, the diamond object is there. So we're going to combine this diamond objects and then combine the circular objects. So this is we call it as a clustering system. So grouping similar objects, we call it as a one type of unsupervised technique. So unsupervised technique is that so problem of finding hidden structure within an unlabeled data. So we should, for example, so we should process some data in the system. So we're going to give some input based on that the system itself produce the so output means that type of technique we called it as a unsupervised technique. So now we are going to see what is called as a K-means clustering. What is called as a K-means clustering? So K-means clustering is that so partitioning clustrical approach we call it as a K-means clustering. So each cluster is associated with the same file. So already I told so grouping similar objects. So based on that grouping similar objects, so there will be the centroid available. With that centroid only all the nodes are so grouped together. So each point is assigned to the cluster with the closest to centroid. For example, so in the previous diagram we have seen so in this circle object, so what are all the nodes which is closest to that centroid? So that is we call it as a so group of nodes combined together based on this centroid. So number of clusters the K must be specified. So based on that grouping objects, with the help of that K, all the nodes are joined together. So with that group of nodes, we call it as a clustering approach. So now we can see one example. So this is the example for K-means clustering. Here we having the sum of the points. So A1 is a 2,10, A2 is a 2,5, A3 is a 8,4, and then A4 is a 5,8, and then A5 is 7,5, A6 is 6,4, and then A7 is 1,2, and then A8 is 4,9. So here we are going to so form three centroids. So we can randomly select that centroid out of this all 8 points. So now I am select. So A1 is a one centroid, and then A4 is one centroid, and then A7 is one centroid. So likewise, I split up as a three centroids. So with that centroids, I'm going to calculate the mean value. So what is the formula for calculate the mean value? So A comma B is equal to probability of A comma B is equal to x1, x2 minus x1, so plus y2 minus y1. This is the formula for calculating the mean value. So with that, I'm going to, so I send a value. So x1 is 2 and then y1 is 10, x2 is 2 and then y2 is 10. So I'm going to apply the value to this formula. So for that, I got the mean value is that 0. So likewise, I'm going to calculate the mean value for that. So each and every centroid. So for that first centroid, I got the values that 0, 5, 12, and then 5. And then a second centroid, so 5, 6, 7, and then 0. And then third centroid, 9, 4, and then 9, 10. So with that three centroids, so I'm going to decide that corresponding node belongs to which cluster. For example, so based on that mean value, so A1, the out of the three centroid, this A1 is belongs to the first centroid, which is called as a 2, 10. So how we can decide this the first centroid is belongs to 2, 10. So we got the minimum mean value is that 0. So out of the 3 value, the minimum value is that 0. So that's why this the first centroid, the first value 2, 10 will belongs to the first centroid of 2, 10. So likewise, I calculate. So all those mean value for see here. So for that first value 2, 10. So it the clusters belongs to 1. So we have the minimum value is that 0. So that's why. So this 2, 10 is belongs to centroid 1. So likewise, so we're going to calculate. So all this mean value. So 2, 10 to 2, 10, 2, 5 to 2, 10, 8, 4 to 2, 10. So likewise up to 4, 9 to 2, 10. So with that calculation, so we should get the centroid value of all those 2, 10. See here, the second value will be calculated. So for the second value, so which one is the minimum value? 5, 6, and then 4. The minimum value we got that 4 in the centroid 3. So the 2, 5 is belongs to centroid 3. So likewise, I calculate all those mean values. So with that mean values, so I decided, so each and every point belongs to which cluster. So the A1 is belongs to cluster 1, and then A2 is belongs to cluster 3, and then A3 is belongs to cluster 2, and then A4 is belongs to cluster 2, and then 5 is also cluster 2, 6 is also cluster 2, and then A7 is cluster 3, and then A8 is cluster 2. So likewise, I calculate all those mean value. With that, I identify. So each even every point belongs to which cluster. So I split up those values into this clusters. So the 2, 10 is belongs to cluster 1, and then A3, A4, and then A5, A6, and then A8. So these are all belongs to cluster 2, and then 2, 5, and then 1, 2 is belongs to cluster 3. So with that, so I'm going to calculate. So new centroid. The new centroid is that 6, 6. How I am going to calculate this 6, 6? So that is the thing we are going to see. See here. So I'm going to calculate 8 plus 5 plus 7 plus 6 plus 4, and that is divided by how much of nodes which is available. So totally we having 5 nodes. That's why we divided by 5, and then 4, 8, 5, 4, 9. So that will be divided by 5. So for that, I got the value as 6, 6. And then cluster 3. So 2 and then 1 is there. So 2 and 1, 2 plus 1 divided by total number of nodes 2 divided by 2. And then 5 plus 2 divided by total number of nodes 2. So for that, I got the values that 1.5, 3.5. With that, so I'm going to create now new centroids. So before that, already we have one centroids 2, 10, 5, 8, and then 1, 2. So with that, so new cluster formations. So I got the values that 6, 6, and then 1.5. So with that, I'm going to create. So again, new different type of centroids. The 2, 10 is the same centroid, and then 6, 6 is a new centroid, and then 1.5 and then 3.5 is that new centroid. So with that, again, I'm going to calculate that mean value for each and every centroids. So I'm going to calculate the mean value for 2, 10, 6, 6, and then 1.5, 3.5. So with that mean value, so again, the new cluster has formed. So 2, 10 is belongs to cluster 1, and then 2, 5 is belongs to cluster 3, and then 8, 4 is belongs to cluster 1, and then up to that 6, 4, it belongs to cluster 2, and then 1 comma 2 will be 3, and then 4 comma 9 is 9 1. So up to the step will be continue until the centroid has not changed. So we compared with the previous cluster and then a new cluster. So the cluster has changed from the previous cluster. Here 1 3 2 2 2 2 2 and then 3 and then 2. So in that new cluster, I got that 1 3 2 2 2 and then 3 and then 1. The last two value will be changed. So for that next step proceed. For the next step continuation, the same cluster will be continue means. So with that, so there is no change in that point value. So up to this, the k-means clustering is over. So thank you all.